stop to think about how fast AI agents are changing. I mean, really changing.
It's pretty incredible, isn't it?
We're zooming past those simple chatbots, the ones that just answer one thing at a time. Now we're looking at these sophisticated digital collaborators. They
Mm.
can handle complex stuff, multi-step tasks, almost like having a virtual team.
Right, like a team of specialists working together.
Exactly. And this is a huge shift because think about it. Without a memory, an AI is basically starting fresh every single time you talk to it.
Groundhog Day for AI.
Totally.
Yeah.
But these stateful agents, they can build on past interactions, remember things, keep context,
Yeah.
like a human colleague would. That feels like the real game changer. So the big question is, how do these complex AIs, especially when they work together, actually manage all that information? How do they save things, share them, pick up where they left off? Well, today we're doing a deep dive into exactly that. We're looking at a really interesting lecture note called Content Operations Saving and Loading Data for AI Agents. It's by Jae Choi, who's an associate professor at George Washington University, and also the principal investigator for the CAFA protocol.
Ah, yes, the CAFA protocol.
Yeah, and just so everyone's clear, we'll be pronouncing CAFA like kappa, K-A-P-P-A.
Yeah, CAFA.
So our mission here is to really unpack the fundamental ways AI manages information flow. Because understanding this is honestly, it's crucial if we want to build truly smart, collaborative, and maybe most importantly, stateful agents.
Absolutely essential.
So let's picture it. A world where AIs collaborate smoothly, passing data back and forth without any hiccups. What's the secret sauce behind that?
Well, what's fascinating and kind of complex is just how involved these multi-step tasks can get for an AI. Think about comprehensive market analysis. That's not just one query.
No, definitely not.
An agent might need to first, say, scrape financial news from all over the web, then pull raw sales numbers from a database, and then synthesize all that completely different information into one coherent, detailed report.
That's a lot of steps, a lot of different kinds of data too.
Exactly. And this gets to the core why of content operations. The stuff an AI produces, it's not just disposable throwaway text, it's valuable content, an asset, really. It needs to be managed, saved, referenced, passed along reliably.
Right, like the output of one step becomes the input for the next.
Precisely. Think of a collaborative pipeline. Maybe one agent gathers the raw data, another does statistical analysis on that data, then a third agent takes the analysis and writes a, natural language summary.
Okay, I see the chain.
For that whole virtual team to work, the handoff of information at each stage has to be seamless. And that's exactly where content operations come in. At its heart, it's about giving agents the ability to save, load, and export data. And the CAFA protocol, Kappa, provides the actual commands to do this.
Okay, that makes perfect sense. It's like giving the AI team a shared filing system and a way to pass notes securely, a kind of digital nervous system.
Yeah.
So we get the why. It's vital for complex tasks, for teams of AIs. But how does it actually work? Like fundamentally, what are the basic commands in CAFA that make this remembering and sharing possible?
Great question. So the absolute cornerstone of the system within the CAPA protocol is the @SAV.
Okay. Basically, whenever an AI agent needs to store any piece of information, could be simple text, a number, a really complex data structure, even the result of something it just figured out it uses at SAVE. And here's the really key part. When it saves the content, the system doesn't just, tuck it away. It gives back a data ID.
A data ID.
Right. Think of this data ID as a unique, secure reference, like a secret key or maybe a pointer to where that specific data is stored. And crucially, to get that data back, you need that exact ID. That provides a really important layer of security. No ID, no data access.
Yep.
Simple as that. Ah, okay.
Yeah.
So the data ID is like the address and the key all rolled into one. That's pretty neat. Elegant, even. So once an agent saves something and gets this data ID back, what can it do with it? Can it, update the data later? Or add more information, like we might edit a file or add notes?
Exactly. It's flexible. So using at SAVE stores the info and gives back that unique data ID, that secure reference.
Right.
That ID can then be used later to load the content. But agents aren't just stuck saving brand new stuff. They can use that same data ID to update the existing data. Basically, overwrite what was there before.
Okay, so you can replace old info.
Yep. Or, and this is pretty powerful, they can append new information to what's already there. Kind of like adding to a running list or log.
Ah, appending.
Yeah, it gives them a lot of flexibility for managing ongoing work or, data that grows over time.
That appending feature sounds incredibly useful. especially for keeping a running record of things. And speaking of records, you mentioned something called the app log using ID log. Can you tell us more about that? Sounds pretty central.
Oh, absolutely. The app log, which you get by using the specific ID log, LOG, is a special case. It's a persistent storage spot within the system. It's designed specifically for tracking important things, significant events, decisions the agent made, maybe user choices.
Okay, like a history tracker.
Exactly. And anything saved to the log is automatically appended. It just adds it to the end, building this continuous history over time. So an agent might use, say, at savee, user selected option A, log, to just note down a key choice the user made.
I see.
And this continuous chronological record, it's fundamental for building agents that can actually learn and adapt based on past interactions.
Fine.
And that brings us naturally to at load, which is, the other side of the coin from at savee.
The retrieval part.
Precisely. If at savee puts data away and hands you the key, data ID, then at load uses that exact same key to get the information back out. It's the core mechanism for moving information around. Could be between different turns in one agent's conversation, letting it remember what was just said.
Maintaining context.
Right. Or it could be between totally different agents, which is how you enable that collaboration we talked about. So if an agent saved some, complex analysis results and got back a data ID, later on, maybe even a different agent could use that load with that specific ID to instantly pull up those results ready for the next step.
Makes sense. And I'm guessing, just like with at savee, there's a special way at load, works with that app log, the log ID.
Yeah.
How does an agent use that history it's been building?
Exactly right. When an agent uses at load, it doesn't just get one piece of data, it retrieves the entire accumulated history from that app log, all of it.
Wow. Okay. The whole diary.
Yep. And this is where the power really becomes clear. It lets an agent review its whole past interactions, decisions, events recorded there. And having that ability to recall the past lets the agent adapt its current behavior, maybe change its response style or its strategy based on what happened before.
So it learns from experience.
It's a direct way knowledge becomes useful, right? It's not just stored, it's understood and then applied to shape what happens next. It essentially gives the AI a memory, a personal journal, which is, a massive leap from those stateless chatbots we started with.
That is incredibly powerful for continuity, for personalization. Wow. Okay, so let's try and tie this all together. What does all this mean for how AI agents actually work in the real world? How do these at savee and the load commands, which sound simple enough, unlock these really tangible, powerful capabilities for us users? Maybe walk us through a scenario or two.
Sure. Let's start with that inter-agent collaboration idea, sometimes called collective AI. Imagine you've got a researcher agent. Its job is just to gather news articles about a specific market. Then you have a separate summarizer agent that needs to boil all that down into concise reports.
Okay, two different specialists.
Right. So here's how the data ID becomes the critical link. The researcher agent does its job, finds a bunch of relevant articles, maybe even cleans them up a bit. Then, and this is key, it doesn't try to send that huge pile of raw text directly to the summarizer. That could be messy, maybe too much data for the summarizer's input limits.
Right, could overload it.
Instead, the researcher uses at SAVE to store all those collected articles. The system saves it and gives back a unique data ID. Let's say it's something like 4A1B8C3D, E2 at zeros, 4G3H, I1J2, K3L4M5N, 607P8. This data ID is now the secure address, the pointer, to that saved collection of articles.
Okay.
Now here's the really elegant part. The summarizer agent, it doesn't get the massive text dump. It just receives that short, simple data ID. That's it.
Much more efficient.
Way more efficient. Its task is just to summarize, so it might issue a command internally like summarize the following text at load 4A1B8C3D, E2S0, 4G3H, O1G2, K3L4M5N, 607P8. The system sees that at load command, uses the ID to fetch the full text of all those articles from storage, and then feeds that retrieved text directly into the summarizer's process.
So the system handles the retrieval behind the scenes.
Exactly. It highlights the elegance, right?
Yeah.
The data ID is this secure, super efficient way to pass data. You avoid slinging huge chunks of raw information between agents. It's like handing someone a library card instead of trying to carry the whole library over to them.
That's a great analogy. Yeah, that seamless handoff is obviously vital for making collective AI work smoothly, much more efficient.
Yeah.
But you also mentioned agent self-adaptation. How does this system let an agent actually learn from its own history and, tailor its behavior, really personalize the experience for a user?
Yeah, and that's where the app log, using ID log, really comes into its own. This is how an agent can effectively learn from its past.
Mm.
Let's say during a conversation, a user clearly states a preference. Something like, hey, from now on, always give me bullet points, not long paragraphs.
Okay, specific instruction?
Right. The agent can then log this using a simple command. At SaveEE, user prefers bullet points, log, boom. That note is now tacked onto the end of the agent's persistent history in its app log,
Stored away.
stored away. Now fast forward, maybe the next day, the same user starts a new conversation with that same agent. Before generating a response, the agent can quickly check its history. It uses at load to pull up its past interactions. When it scans that log and sees the note, user prefers bullet points, it knows immediately how to format its new response. It'll use bullet points.
Automatically adapting based on past preference.
Exactly. It's incredibly powerful. The log gives the agent that crucial memory, allowing for a truly personalized, adaptive experience that evolves over time. It's a beautiful demonstration of how knowledge isn't just about storing facts, but about understanding and applying them to future actions.
Okay, these capabilities, collaboration, self-adaptation, they're clearly super powerful, huge potential. But whenever we talk about agents saving and sharing information, especially potentially sensitive stuff, my brain immediately goes to security. It has to, right?
Absolutely, it's paramount.
So what are the critical safeguards here? What do people need to understand about keeping this data safe, especially concerning these data ID?
Yeah, that's a critical point we absolutely need to cover. As powerful as these content operations are, that data ID, it is the key to the data. Managing it responsibly is, well, it's everything. You really have to think of the data ID not just as like a file name, it's the password to a locked file.
Okay, treat it like a password. Got it.
First rule, treat the data ID as a secret. Always. The security of whatever content it points to hinges entirely on keeping that ID confidential. If it leaks, you've basically just given away the key. This is why those system-generated GIDs, the long, random-looking strings of characters, are inherently better for security. They're random, virtually impossible to guess.
Unlike maybe naming it something obvious.
Exactly. Which brings me to the second point. Handle sensitive information with extreme care. This temporary storage mechanism is fantastic for operational data for passing things between steps, but it's generally not designed or suitable for highly sensitive personal data that needs, long-term audited, super secure storage.
Right, it's more like a temporary workspace.
Precisely. And if you do find yourself needing to handle sensitive info temporarily using this method, absolutely do not create human-readable data IDs that reveal anything about the content. Like an ID such as user Jane Doe medical record, that's a huge mistake. It creates a massive metadata risk just by existing. You're revealing context in the ID itself.
Yeah, that makes sense. The ID should just be a random label, essentially.
Yeah.
Keep the sensitive stuff inside the container, not written on the label.
Exactly. The ID should be non-descriptive.
Okay, that's a crucial distinction. Don't put secrets in the file name, basically.
Mm-hmm.
So what happens after the data's been used? Especially if it was sensitive, how do you make sure it's gone? Is there like a digital shedder function?
Absolutely. And it's a really vital security practice of telling you the data after use. It is effectively digital shredding. Once that sensitive information has served its purpose, like after our summarizer agent has loaded and processed the content pointed to you by a data ID, you should have a process, maybe a dedicated cleanup agent or step, that then executes a command to overwrite the content associated with that data ID. For example, something like @SaveE, data overridden for security, 4A1B, 8C3D, E2S0, 4G3H, I1J2 DAC, K3L4, M5, and 607P8.
Ah, so you replace the real data with junk text using the same ID.
Exactly. You replace the original sensitive content with something meaningless. This renders that specific data ID useless for retrieving the old information. It significantly cuts down the risk of old, forgotten data remnants being exposed later.
Digital hygiene, basically.
Precisely. And it's also really important for everyone to remember this storage provided by content operations in the CAFA protocol. It's fundamentally not permanent storage.
Right, you said temporary transitional.
Yeah, think of it like a digital clipboard or maybe RAM in a computer. It's a short-term memory buffer. It is not a permanent database designed for long-term archival. System administrators might even periodically wipe all data just to manage resources, which, by the way, also acts as a security feature. It reduces the time window that old data might be exposed.
Good point. Less old data lying around is generally safer.
So the takeaway is never rely on the system for keeping data forever. If data is critical and needs to be kept long-term, make sure it gets exported properly to a secure, dedicated long-term storage solution, like a real database or an archive system. It really brings up the whole important question of managing the full data lifecycle within these complex AI systems, doesn't it?
It really does.
Yeah.
Okay, so let's try and wrap this up. This deep dive into the CAFA protocol's content operations, focusing on at CV and at load, it really paints a clear picture, I think. These are the fundamental building blocks enabling these more advanced stateful AI agents we're starting to see. We've seen how they unlock really two critical capabilities.
Yeah.
First, that seamless inter-agent collaboration, where agents pass work along using those secure data ID pointers.
Yeah, the handoff.
And second, that powerful agent self-adaptation, especially using the special ALGA ID, which lets agents remember, learn from their past, and actually evolve their behavior over time,
The memory aspect.
right? And underpinning it all is the data ID as that secure pointer, and the absolute necessity of managing it responsibly, following best practices like overwriting data and treating IDs like secrets.
Couldn't have said it better. And as these AI agents get woven more and more tightly into our workflows, into our personal lives, understanding how they manage their memory, how they communicate, and how they secure that information, it stops being just a technical detail.
Yeah, it becomes fundamental.
It becomes fundamental to trust, to responsible AI development. It really makes you think, doesn't it? What does it mean for the future when our digital partners can't just process information, but can actually remember, learn, collaborate on really complex jobs, all while managing security in this dynamic way?
It changes things.
It totally transforms how we think about information itself and maybe even intelligence. Lots to chew on there.